Hello, good morning. Good morning. Today we are going to discuss about the subject digital signals and system. So today first I would like to introduce myself. That is, I am Kausar Taj, Assistant Professor, Department of Robotics and AI, SSIT Sahay Tumkur. So our subject which we have to discuss today is digital signals and systems. So before the content of today's session are content of this today's topic which we are going to discuss are signals. What are different types of signals? Then what are the difference between analog and digital signals? Then we are going to discuss about what is a system. Then we are going to discuss about what is the main importance of frequency domain analysis. So we are going to discuss about the frequency domain analysis. So let's start with signals. So signal, what is a signal? Anything which conveys some information is called signal, okay? And anything, a signal is a physical quantity, so which varies over time. Then we can define the signal in plenty of different ways. So depending upon the field or the domain we are using and observing and defining a signal. So in general, if you want to speak, what is a signal? A signal is nothing but anything which carries information is nothing but a signal. So another way if you want to define a signal is a physical quantity that varies over time and it carries some data. So another way of defining it is a quantity that changes over time or in space and have some information is called signal. So in another way also we can define like a signal, it is nothing but gestures or actions that convey some information is also a signal. So here are the list of examples which conveys what is a signal in real time is. So some of the examples of the signal are, so for example, it can be example of the signal is acoustic signal and electrical signal. So acoustic signals are nothing but the speak signal which we speak. So that is whatever the signals we are speaking. So it is a acoustic. It echoes and it goes to the other person. So that is acoustic signal. So another is electrical signal, so which forms as an electric. So whenever we are speak through a microphone, the information going to pass as a electrical signals. Okay. So then other form of example of the signal is video signal. So how in a video signal how information will be represented at the signal? What are the signals we are going to get? So in the video signal, the informations are represented in the form of intensities. So as in the form of x, y and the t parameter. So that there is a variation seen in all the in the video signals. The intensities varies over time, and this variation gives us some information. So that is regarding video signal is an example. Then we have biological signals. That are the main basic signal, that is biological signals. So you know the EEG signal, ECG signal and many other signals from our body we know. And each signals carries some information. The best example is ECG. So what is the ECG signal? What is the information we are going to get from the ECG? So we have its own pattern, that is PQ, RST. So any changes in the amplitude or the variations give some signal about the ECG. So then EEG signals, where different forms of in the EEG, it is nothing but electroencephalogram. So in EEG also we have different we have alpha, beta, gamma waves. It has its own frequencies. So any changes, if any issues with the health, the brain signals, it gives us what actually is a problem. What is in the whole, what we can say is, what is a signal is, it is a quantity which gives some information. So either it is a real time, in everywhere in around the world, every parameter, every occasion is giving a signal. Okay, that is a contextual meaning of what is a signal is. So if you come further with the examples, so these are the main examples. Then when we go for what are the different attributes of a signal. So the main, as we know, the main attribute of a signal is amplitude, frequency and the phase. So what is a amplitude? So what is a frequency and what is a phase? Let's discuss. So first let's go to the first term, which is the main attribute of the signal, is the frequency. So what is the frequency? So frequency is nothing but, so we know that the frequency is nothing but number of cycles per second. So whenever we want to discuss, whenever we want to say any signal has a frequency, the signal should be a repeating event. It should be repeating. Then only we can say it is a frequency exists for that particular signal. So if the signal does not repeat, then the frequency will not be there. We can't say the signal have that frequency. So in overall, what we can say is frequency is nothing but number of occurrences in any repeating event. So in this example, you can see that, so this particular figure has 4 cycles. You can just see that, so this is one cycle and the same cycle is repeating second time, same cycle is repeating third time and the last cycle is repeating another time. Total, we can say that the same information is repeating how many times here? 4. So what is the frequency of this signal? We can say that the frequency is 4 cycles per second. So similarly, this example you can see that, so as the number of information is repeating more number of times, so the frequency of this signal is more. Example in this is 14 cycles. The signal repeating 14 times. So if you want to tell the frequency contextually, we can say that the best example in the nature is the occurrence of day and the night. Okay, if I want to give the example as a contextual example. So contextual example is nothing but occurrence of day and the night. So it does day after day, is night exist? Yes. So after night, does day occur? Yes. So the frequency is there. Okay, it is a contextual example. So then going to the next attribute of the signal, which is amplitude. What is the amplitude? We know that the amplitude is defined as it is a strength of a signal. So it is a strength of a signal at a given interval of time. So if they are given a particular interval of time, what is its amplitude? See, in this example, you can see that there are different amplitudes. See, this is the first, the signal in the red has one amplitude, the signal in the green, the signal in the blue has different amplitudes. So amplitude is nothing but the strength. You can see that the strength of the red signal is 20 volts and the strength of the green signal is 60, and so like the strength of the blue color signal is 100. So high amplitude, blue color you have the high amplitude, green is have the median amplitude and the red is having the low amplitude. So basically amplitude is nothing but the strength of a given signal. So next coming to the phase. So phase is nothing but a number of what is a completion of one full wave. Okay, so phase at what point it starts and at what point it ends gives a phase. So completion of one full cycle gives a phase. So if you take this example of red and the blue signal, sine wave or a sinusoidal signal, you can see that the blue color is starting and it is completing its cycle at this point, and the red color signal is starting at this point and it is ending here. So the phase of the signal, you can see that the phase of both the signals are different in this case. So these are the basic attributes of the signal. So next we will go for the next thing, that is classification of different signals. So as of now we seen that what is a signal, what is the meaning of a signal, what are the different examples of a signal, and also we have seen what are the main attributes of a signal basically. Next, different types of the signals. So these different types of the signals depends generally as well as the basic types. So let's see which are the different classification of the signals. The different classification of the signals are, so continuous time signal, discrete time signal, so analog signal, digital signal, then we have deterministic and a random signal, even signal, odd signal, periodic, aperiodic signal, and energy and the power signal. So these are the different classification of the signals. So now let's see one by one what are the different classification and what are they. So first, continuous time signal. So what are the continuous time signal? So continuous time signals are the signals whose amplitude is continuous over time. So example of the continuous time signal, you take temperature, you take pressure, you take the sound signal, then you have the current from a current sensor. All those are the examples of continuous time signal. To understand deeply this continuous time signal, what is a continuous time signal is, so you take whatever may be the interval you can get. See, in this time period, you take whatever may be the interval. So there the amplitude is present. The signal has its own amplitude. So that is meaning continuous time. So you take whatever may be the interval, the signal is present. So these are some examples. You take the current, currently is measuring in a current sensor. Then the temperature, the best example is temperature. So you take whatever may be the interval of time, the temperature exists in the nature. So these are the real-time examples of how we can understand the continuous time signal. So let's move on to the discrete time signal. So discrete time signals are the signals whose amplitude is present only at the discrete interval of time. So meaning, so as like in the continuous time signal, the amplitude is present in all the intervals of time. You take whatever may be the fraction of time, and if you check, there is a amplitude of it. But in the discrete time signals, so we can see that it does not occur present in all the intervals. Only in the discrete intervals, we can see that there is a amplitude present. See in this, the example of this figure, you just see that. We can see that. So there is a amplitude and yes. So you can see that. So the amplitude, if you want to say, just take an example. So if the signal is, if you take the interval as 0, 1, 2, 3, etc. So if you want to check the interval at 0.5, we can't get. Why? Because we are sampled this signal. We are going to get this discrete time signal by sampling this analog signal. So, and we have taken the samples and the equal interval of time. Hence, so if you are checking in between the samples, maybe we are not going to get the amplitude. So that is the definition of discrete time signals. So next, moving on further. So these are some real-time examples. I have just listed the real-time examples so that how one can understand better what is a discrete time signal is. See, that is, for example, you just take the rate of any material or gold or anything which is any quantity which varies only a fixed interval of time, and we can't get it in between. That is the example of discrete time signals. Next is, so we understood about the continuous time signal and the discrete time signal. So next types of signals are analog signals and the digital signals. So let's see what is an analog signal. As I told earlier, so the major difference between the continuous time signal and analog signal is, you know that, so analog signal is nothing but it is a continuous time signal with continuous change in the amplitude with time is called as an analog signal. So analog signal is a type of a continuous time signal. So whose amplitude will be continuously we are going to get and we are going to get over time is analog signal, and usually it is represented like x of t. Generally it is a user variable which can change over time. So example of analog signal is, we can best, telling the real time example. So the best example of analog signal is the human voice. So the example of human voice is, so you can see that, so the variation of the amplitude is continuous. So once we are speaking, so you can see that, see till I stop, the duration from I start and stop, the variation and the amplitude is continuous. So hence the example of analog signal contextually is the speech signal. So then coming to the digital signal. So what is a digital signal? A signal that is sent and in the form of binary digits, and the signals which is represented by the binary digits like 0 and 1 are called as digital signals. So here you can just see that So this digital signal, you can see either the two amplitudes are present for a given interval of time, either it can be 0 or it can be 1. So if you want to talk about the voltage levels, usually this logic 0 signal or 0 level is usually called as 0 volts, and this high level, which is usually represented as plus 5 volts. So that is a digital example of digital signal. So I'm giving these examples as a real-time examples. Why? Because understanding the basics related to the real-time environment is very essential to understand the concept further. So the next types of signal, let's move on to the next type. The next type of signals are deterministic signal and the random signal. So let's understand what are deterministic signal and the random signals. So the deterministic signals are the signals whose behavior is known and can be represented mathematically. So are called as deterministic signals. So example we can give as sinusoidal signal or ECG signal. So why this sinusoidal signal or ECG signal we can call it as a deterministic signals? Because their behavior we know. That is, so if I take a sinusoidal signal, we can represent that using the mathematical formula, that is AC is equal to cos of 2 pi FCT plus phi. So where A is the amplitude, so F is the frequency and phi is the phase. So any sinusoidal signal can be represented using mathematical form, hence they are deterministic. Taking the next example, which is ECG, we know that, so ECG have a PQRS pattern, and any changes, the PQ has its own amplitude and PQRS complex it has own. So each complex has its own amplitude level. So if any changes in the amplitude levels leads to gives some information, and hence these two signals and many more are there. These are some examples we have listed. So then coming to the random signal. So what is a random signal? A signal which can't be represented using mathematical form and whose behavior we don't know. See, we can't predict the behavior of that particular signal. Such kind of signals are called as random signals. The best example of a random signal we can give is the noise signal or any noise signal. So here you can just see that random signal, the noise signal does not have its own pattern and it can't be represented mathematically. Why? Because so noise has its own random way of representation, okay, and it does not have the predicted representation. Hence, so this is regarding deterministic and the random signal. So let's move on to the next type of signals, that is even and the odd signal. So what are even and the odd signal? So assume a given signal is represented as x of t or x of n. So the signal x of t or x of n is said to be even if x of minus t is equal to x of t. That is, if you are reversing the signal in time, the reversal signal and the actual signal becomes exactly the mirror image. So the best example of an even signal, as a contextual example, we can define it as a parabola. That is, if this is the signal from 0 to this part, if it is a x of t signal, if we mirror image it, then we are getting this. That is, so the mirror image of the signal and the original signal is same, then we are going to call it as the even signal. So the next example is next signal is odd signal. So in the odd signal you can see that if any signal I want to say it is an odd signal, so assume x of t is a signal or x of n is a given signal. If this x of t or x of n is said to be odd, so what is the condition need to be satisfied? So x of minus t in continuous time, x of minus t is equal to x of t, and discrete time x of minus n should be equal to minus x of n. So there is a x of minus n is equal to minus x of n. That is, you can see this example, this is x of n signal, and if we mirror image it, we are not getting the same like reflection of the signal. So in other way, if you want to define what is the even signal, So the one part is completely giving the reflection and the other part is even signal. So it is not the case in case of odd signals. Whatever the signal we have having, if we flip it, it's not giving the mirror image, and in turn it is giving the some other pattern. So this is an example we can give for odd signal. So here there is a correction, x of minus n is minus x of n. X of minus n is minus x of n. Yes. Then the another type of signals are periodic signals and aperiodic signals. So what are the periodic signals? So periodic signals are the signals which repeat at a given interval of time, after a given certain interval of time. So it repeats its value in given t period of time. So where what is this t is given a fundamental period t. So we are going to represent the periodic signal as this: x of t plus t is equal to x of t, where x of t is a fundamental signal. So one contextual example of the periodic signal is we can give as a leap year. So why leap year is one of the example of the periodic signal is, see, this leap year going to repeat after 4 years. So after every 4 years the leap year is going to repeat. So hence the periodic signal best contextual example or real-time example is leap year. Or other example which we can give for periodic signal is occurrence of day and the night, which has its own period of 12 hours each. So then going to the non-periodic signal. So a signal which does not repeat over a given interval of time, that kind of signals are called as aperiodic signal. So best example of aperiodic signal is random noise signals, okay, which does not repeat. See, we don't know what is a period. So the amplitude which we are noting may not continue after a given interval of time. Hence, that type of signals are called as random signals. So this is an example of periodic and non-periodic signals. So let's move on to the next type, that is energy and the power signal. So what are energy and the power signal? So energy signal is defined as if the total energy content is finite and average power is 0. If the total energy is finite but average power is 0, so that kind of signals are called as energy signals. So the example again I am giving the real-time example or the contextual example, so that this energy signals you can understand it better, is non-rechargeable battery. That is, it is having some energy, okay, it has some finite quantity of energy, but the power is average power, if you consider it is 0. So we can define the energy signals of the batteries. Coming to the power signals, and these power signals are, what are the signals? The power signals are, if the total power content is finite but average energy is infinity, then so the total power content is finite but average energy is infinity. In such case, the power that kind of signals are called as power signals. So you can just see the example. So the example of, we can give the power signal as real-time example as sun. Why? Because it has an infinite energy but finite content. Moving on to the next type of, so this finishes the different types of signals. So starting from continuous time, random, periodic, aperiodic, and finally the energy and the power signals. So these are the different classification of the signals. So apart from that, so there are some basic signals which we are going to oftenly use in our digital signals and systems. So let's understand those signals. So these basic signals form the base of digital signals and systems further. So let's go on to that basic signals. There are 5 basic types of signals. One is unit step, unit impulse, sinusoidal signal, then we have unit ramp signal, then exponential signal. So let's see one by one what are those. So first is unit step signal. So unit step signal is defined as, So u of n, its representation. Usually the representation of the unit step function is u of n, and it is defined as it is having an amplitude 1 for the interval n is greater than or equal to 0, and it is 0 when n is less than 0. Okay, so then you can just take this example. The representation, waveform representation of this is, see, in the waveform, the signal starts at 0 and it continues for whatever the given n value, but if you take less than n value, it is 0. So then we have the unit impulse function. So next, defined as the signal delta of n. It is represented, its representation is delta of n, and it exists only at n is equal to 0 and does not exist for any other value of n. Only it exists at n is equal to 0. That kind of signal is called as impulse. So this waveform representation is showing about, so n, so this is a negative axis, this is a positive axis, and the signal exists only at n is equal to 0. Then finally we have the sinusoidal signal, so which has the amplitude which is represented as x of t is equal to a into cos of omega t plus or minus phi. So here you can just see that where a is the amplitude, so w is a wavelength, and phi, so this w is represented as 2 pi ft, so here where f is a frequency. So it has a representation as sinusoidal signal. So for a given amplitude, for a given frequency, this is how the sinusoidal signal is represented. So the next form of signal is exponential signal. So it is defined as x of n is equal to a power n for all the value of n. So depending upon exponential, have exponentially increasing, exponentially decreasing. There are two types in the exponential signals. So what are those? Let's see. When it will be exponentially increasing, when it will be exponentially decreasing. So we are going to see here. So whenever a is less than 1, the exponential sequence x of n is said to be growing exponentially. When a, whatever the amplitude a is there, a is, whenever a is less than 1, it is growing exponentially. When a is in the range greater than 0, but it is less than 1, in such case it is exponentially decaying. And whenever it is a is less than 0, the signal it takes alternating signs. So depending upon value of n. So these are the example of exponentially increasing, this is exponentially decreasing, and when a value becomes less than 0, it takes different forms. So then the last type of signal are the ramp signal. So the ramp signal is represented as this. R of n is a symbol which is used for representing ramp signal, which is equal to n for n greater than or equal to 0. So this is a representation of the ramp signal. So whatever the n value, it keeps on going. So today we understood about what is a basic definition of a signal. So we have discussed many contextual examples of a signals. So what is a frequency? We have understood what is the basic attributes of a signals. Then we also discussed about different classifications with real-time examples. So then we have a basic signal times in this session. Thank you.